So I'd like you to take a minute to try these first two questions on your own. Pause the video, and when you're ready, hit play and start again. So I'm looking to rewrite 4/5 as the sum of two fractions. So we're working with fractions when I am adding, because sum means to add. I need common denominators. So I can write this as 1/5 plus 3/5, or I could write this as 2/5 plus 2/5. It doesn't matter. In my next question, I'm looking to do the difference, which is subtracting. So I still need common denominators. I can write this as 6/5 minus 2/5. Now 6/5 is an improper fraction, but that's okay. It doesn't matter in this case. I could also write this as 5/5 minus 1/5, and so on. So now we've worked with fractions before in middle school. We're still going to work with fractions now, but we're going to jump to this next question here. My next question has a binomial in my denominator. The rules don't change. So when I am adding or subtracting, when I am combining fractions, whether it's an integer or whether it's a binomial, my denominators have to be the same. So I'm going to write this as x plus 5 plus x plus 5, like we just did up above. And my numerator is a 2. So if I go back to this first question, I wrote it as 1 plus 3 or 2 plus 2 right here. So I'm going to do the same thing down here. 1 plus 3, or I can write this as 2 over x plus 5 plus 2 over x plus 5. And now we're going to jump down to our last question. Our last question here, not only is my denominator a binomial, which I'm going to set up again as x plus 1 plus x plus 1, but my numerator is also a binomial. So we have to be careful with our rules for combining like terms. So I'm going to start with x and 4. When I combine those in my numerator, x and 4 are not like terms, so I can combine them together. However, I could also write this as x plus 2 plus 2. And here's why. When I combine into a singular fraction, this becomes x plus 2 over x plus 1. And then my like terms in my numerator are here. So this becomes x plus 4 over x plus 1, which is what I originally wanted. So I want you to keep these rules and these ideas in mind as we go through some of these next questions. So here's something I want you to think about. It's not on your worksheet, but before we jump into our first question. 10 divided by 5 and 12 divided by 5. Hopefully, you know that 10 divided by 5 is a whole number because 5 is a factor of 10. So 10 can be split into 5 to 10. And hopefully you know that 5 is not a factor of 12. So if I were to divide, if I go like old school here and I divide, I would have 2. 2 times 5 is 10. I would subtract and I would get my remainder of 2. So I would write this in terms of a division problem as my quotient is 2, plus I have 2/5 left over because 2 is my remainder and 5 was my divisor. Also as a mixed number, or I could write this back in middle school as 2 and 2/5. So what we're going to be doing today is taking a shortcut for division, because this process, which we just did over here on the side, can sometimes get long. Right now I'm dividing 12 and 5, not so bad. But if I have polynomials, sometimes division can take a while. But I want you to think about something. Can you recognize that 12 can really be broken into 10 plus 2? Because now this is what we did over here. So this is really 2 plus 2/5. And that's the basic idea of what I'm going to show you in these next two questions. It doesn't work all the time because sometimes it's not so obvious to recognize it, but when you can recognize it, it makes it that much quicker than doing long division. So let's take a look at some polynomials. Divide x plus 4 over x plus 1. So I'm going to keep flipping back and forth. I actually am going to put it up as side by side because I want to keep referring to this here. Over here, I referred to this as a fraction, but I can really make this 10 over 5 plus 2 over 5, just like we did in all of those first examples, and that's why we did that. So I want you to keep that in mind. My goal is going to be to break this into two fractions with the common denominator of x plus 1. And I want to be able to reduce. In this case, it was 2. But what if I just had 7 over 5 or 8 over 5? I can write 8 over 5 as 5 over 5 plus 3 over 5. And then this reduces down to 1 because anything divided by itself is 1. So my goal is going to be to make this part the same so that way this piece reduces to a 1 because this is going to be what my answer looks like. So I have an x plus 1. I want to make it x plus 4. So that means it needs to have a plus 3. So this part is plus 3. So my overall answer is 1 plus 3 over x plus 1. Now, we already know how to divide with long division or synthetic division. So if I wanted to check my work, I could. So if I'm checking my work with synthetic, I have x plus 1. Sorry, I have x plus 4 over x plus 1. So negative 1 goes on my shelf. 1 and 4 get lined up. My 1 gets brought down. 1 times negative 1, negative 1. This is 3. This is my remainder, 1 plus 3 over x plus 1. Same answer. I'm going to set it up over here again with my next question. So remember, my goal is to get this into x minus 8 plus x minus 8. And I always want this piece to match because I want it to reduce to 1. So that means right now I have x minus 8, but I want it to be x minus 6. Sometimes with our negatives, it gets a little confusing. Off on the side if you need. I have a negative 8 plus blank, and I want it to equal negative 6. So if you need to set up a little equation, hopefully you can recognize that you need a plus 2. That means my final answer is 1 plus 2 over x minus 8. Once again, if you want, you can check. If I'm going to check with synthetic division, my 8 goes on the shelf. 1 and negative 6 get lined up. 1 gets brought down. 1 times 8 is 8. This gives me a 2. 1 plus 2 over x minus 8. There's my check. So this is called division by inspection. So when it's a binomial that is easy to recognize of how to break apart and reduce down, because go back to my numbers over here. That was my goal, to reduce down. We didn't do any examples where it reduced down to 2, but you will see some. And if you can pick up on that, it gets even faster.